Hello class, welcome to our lesson today dealing with section 10.1. This is the basic building blocks of probability. Many of you will probably find this a little bit too simplistic as we go through, but we want to make sure that our basic groundwork is laid in order to be successful in probability later on. So it's mainly looking at different events and different outcomes that are possible. So let's go ahead and get started. First thing we're going to look at is just solving for x with the two-step equation just to review. So let's look at this one on the left side here, or excuse me, the right side. I'm going to subtract 2 on both sides to get rid of the plus 2. And then I'm going to get 7x equals 38. And then when I solve for x, I'm going to divide by 7 on both sides. Don't forget that this is 38 over 7, but you can simplify that down to a mixed number if you want, 5 and 3/7. You could do a decimal here, but I wouldn't suggest that because dividing by 7 is kind of annoying and kind of repeats after a lot of decimal or a lot of places after the decimal point. So you might be better off just leaving that as a fraction as you're looking at that situation. On the second question, don't forget when you add 5 to both sides here, this is a negative 20 to start with. So really it's a negative 20 plus 5, which would be a negative 15. Make sure you try this one out. See if you can get an answer for that question as you're going through this presentation. Go ahead and try this one out and make sure that you're able to get to the correct answer. Let's say in theory we had you toss a coin 10 times, and I'm going to have you record the number of heads and tails you get. If you toss the coin 10 times, what should happen is you should get half heads, half tails, 5 and 5. How many did you get? Well, obviously that would depend on your tossing of the coin. So some people might have got 6 heads, 4 tails, or 7 and 3. If you got 10 and 0, I'd find that unlikely, but I guess it's possible. What this tells us is that what should happen in theory doesn't always happen in practice. So there are times where we have an idea about what should happen, but what actually happens doesn't necessarily work out as we intend. So we're going to keep talking about that type of idea, but you want to keep in mind that in theory what happens, and then in actuality what happens, they may be slightly different. The goal is that they approach each other, though, as you get more and more tosses of the coin, for example. Okay, so this spinner spin 20. You spin it 20 times. It says how many times should you expect to land on orange. Well, since there's 5 choices, really what you have to do is take how many spins times the probability you get that spin. And so this would be 20 times 1/5, which means I should expect 4. Would this happen in actual life? It's unlikely to occur that it's exactly 4, but 4 would not be an unusual circumstance. However, if I spin the spinner 200 times, it's going to get closer and closer to the correct probability. So this would be true in any game situation. If you've ever played and something happened just absolutely insane that really worked against you or really for you, like you rolled a bunch of numbers and you got the same number a bunch of times in a row, or you drew the one card that actually allowed you to win, that is very unlikely to occur. But over the course of more and more games, it's probably not happening over and over again. So that's something that you want to think about, is as we increase the number of trials or increase the number of times we do something, we should get closer to the theoretical probability compared to what the experiment or whatever happened in real life. We're going to use rock, paper, scissors to also explain a few things here. Remember, rock, paper, scissors has 9 possible options because if player A picks rock, player B could have picked rock, paper, or scissor, and then you can do the same thing with paper, rock, paper, scissor, and then scissor, rock, paper, scissors. So there's 9 options. And what's nice about the game of rock, paper, scissors is it's actually a balanced game. There are 3 ways to tie. We both get the same thing. And then there's 3 ways player A wins. So if you see here, A wins when I play paper against a rock, or scissor against a paper, or rock against a scissor. And then vice versa, player B would win for the same thing. So in actuality, you have the exact same probability of winning. Now some people would disagree with that because they know the tendencies of the player they're going against. But if you just start playing against someone you've never played before, we have the same probability of winning. We both have the same probability of winning and also of tying. But there's 9 possible options. That's okay that some of the options are the same. So for example, this tie is the same result as this tie, but it's still a different option because there's a different setup to how we both tie to find that answer. Okay, I've talked about a few of these definitions already, but let's just go through some of these again and make sure that we're clear on some of them. So the first thing you want to know is what an experiment is. So an experiment is going through a procedure or some type of work to find a result based upon something. So that would be like the tossing of the coin a bunch of times. That would be an experiment. All the possible results are called outcomes. So for the rock, paper, scissors, these are the 9 possible results or outcomes that are possible. A collection of all of them is the event. So the event would be play one game of rock, paper, scissors. And then the favorable outcomes would be the ones that match up with what you're trying to say. So if I want to say find the favorable outcomes of getting a tie in rock, paper, scissors, it would be both rock, both paper, or both scissors. So one of the common questions in mathematics that deals with probability is picking marbles out of a bag. That's one of the staples of math textbooks and math classes for years and years. So here's the marbles that are in the bag. So there's 1, 2, 3, 4, 5, 6 marbles. And it says find the event of choosing a green marble. And so what are the favorable outcomes? There are 2 favorable outcomes, and they're called green and green. In a way, it might be better if we numbered these, even though the numbers don't matter. Because there's 2 different green ones, there's 2 different options that are possible for choosing the green marble. So you have to make sure you dictate that when you are showing your answers on a question like this. Your book uses a number cube, so that's a number or numbers on a cube. We also call that like rolling a die. The possible outcomes here are 1 through 6, so 1, 2, 3, 4, 5, 6. The favorable outcomes to rolling an even would be 2, 4, 6, because remember the even numbers start at 2 and then are just those multiples of 2. What are the favorable outcomes for rolling a number greater than 5? Well, there's only one number, and that's the number 6. Every other number is going to be 5 or less. And since I want a number greater than 5, that would be the only favorable outcome for that situation. For the spinner here, how many possible outcomes are there? It's not saying how many colors can you spin. It's saying how many areas are there. So there's 6 different areas to this. That's why there's 6 outcomes, not 3. Not 4 for the 4 colors. How many of those 6 outcomes are red? Well, 3 of them are red. How many ways can you spin not blue? Well, there's 5 ways. And what are they? Well, it's red, 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 and purple and green. Notice I had to write red 3 times, and that's to showcase there's 3 areas of red as opposed to just 1 area of red. So when you're asked to find the favorable outcomes, that's not how many, it's what are they. So you want to make sure on your homework you're clear that you're looking for what are the favorable outcomes, you write them out. If you're looking for how many favorable outcomes, it's the number. Okay, we're going to be looking at that as we deal with section 1. It's not that this section is difficult, but you got to make sure you read the directions correctly in order to get the answer. Many of you will recognize this icosahedron. This is a 20-sided die, or people that are involved in board games call it a D20 for 20 sides of the die. The possible outcomes are 1 through 20. You could write that in a couple different ways. Notice I did 1, 2, and then I ... 19, 20. That would explain the pattern. Or 1 through 20. The favorable outcomes for rolling an even, for right now it's probably easiest just to do 2, 4, ... up to 20. Favorable outcomes for rolling a number greater than 5 would be 6 to 20, and same idea here. So these questions were actually the same as the other number cube or die that we dealt with earlier, but when we're finding that situation, we want to make sure that we're able to look at that answer based upon the number of sides of the die as opposed to just assuming it's a 6-sided die. So I want you to make sure that you know that a 20-sided die is an icosahedron, so make sure you write that down somewhere as well. In case you're into dice rolling, there is a 100-sided die. This is just interesting to me. It's called a zokihedron, and it kind of looks like a golf ball if you look at it. It kind of just has dimples like a golf ball does. And so when you're looking at that situation, it's named after the man who developed it, Lou Zoshi. And it's hard to tell what number's really on top then at that point. But it's kind of interesting to see a 100-sided die. It's a fairly large die, too, compared to the 6-sided dies that we're used to. The largest fair die is 120 sides. And I guess I'll let you try to say this. Is it Didacus trichondrihedron? Okay, it's 120 sides. And the key with a fair die is you have to find ways to make the shapes all the same and have an equal likelihood of being chosen. So this is different than like a random number generator where I could develop anything I want. A fair die has to have these balances in it. And so you want to make sure that you're looking at it from a balance standpoint, which is why the 10-side or the 6-sided die works so well, and the 20-sided die is used a lot because they're very balanced and should have an equal likelihood of all the numbers to be chosen. You have a lot of questions on your homework, but they should go very quickly. Remember, there's a difference between how many options are there and what are the favorable outcomes. If you're asked for how many, that should be a number. If you ask for what are the favorable outcomes, that should just showcase what they all are. So like the red, 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 blue, purple, for example. You want to make sure that you explain that. You can abbreviate some things. You don't have to write down all the words in their entirety if there is a lot going on there. But you need to be able to write down what all of the favorable outcomes are as opposed to how many there are. That might take you a little bit more time. Make sure you're reading the directions in order to be successful on your homework. Have a good day, everyone.